My name is Natalia, and I'm a research scientist at MIT. And for the next 20-ish minutes, we're going to talk about things you have seemingly already touched upon during this conference: glasses, XR headsets, healthcare, also some extreme environments, with a little change. And this change is going to be about the user, and more specifically about how the user feels, what they think, what they were thinking, and what they will think. It's really interesting to have a conference about XR, but we are barely touching the user of XR. So I'm going to try to unveil what is the actual future, which is going to be not a screen, not a lens, but understanding what you think, how you think about it, and what you will think about it. So, no surprise, I do work with different HMDs, earpieces, glasses, eyewear, all enhanced with non-invasive brain sensing technology. I specifically use technology called EEG, or electroencephalogram, or FNIRS. And over the past 15 years of my research career, I have been doing a multitude of different applications: drone control, gaming, mind-sent interventions for children, extreme environments, and I'm going to touch upon some of them during this talk. So why should we care? We have all of these issues: cloud compute, there is all these jerks in the system, delays, like brain sense, and yeah, that's not happening. Well, spoiler alert, it is. I can see at least 25 people right now in the room, I was counting while we were having all these announcements, having a pair of regular glasses on them. And I bet that almost all of you, if not all of you, are having some type of AirPods in your purse, backpack. If you don't have them with you or on you, you definitely have at least a pair or two in your office, in your space where you live, where you share the environment. I'm not even talking about masks, another paramount part of our lives that we wear on our heads. And all of this helps bridging the gap. Note how I didn't even mention any XR headsets, because you don't even need to have a lens to have access to your brain. A lot of people talk about brain-computer interfaces, but I do like to talk about biosignal-computer interaction, or even integration, or BCI as API. And why does it matter? If you're going to just take the head, we're not going to even go through the whole body. Head. If we're going to put sensors on the back of your head here, we can pick up your imagination. For example, you might want those sushi during the dinner today. We can pick this up. Or maybe you want a croissant. It's a breakfast food, you want it. If you're gonna move further along and move sensors here, it's a premotor and motor cortex. We can pick up motor imagination when you imagine movements. Fun fact, we can pick it up even if you're just planning for a movement. As with a lot of sports players, if you're going to move further along around the forehead, we can pick up cognitive load. We can pick up attention. If we move to the eyes, we can pick up other types of attention without any use of cameras. Also, we can pick up auditory attention. Yeah, you heard me right. If you put sensors around your eyes, I can tell you to which soundtrack you are paying your attention. I don't even need to pick up any sounds around your temporal cortex, here around your ear. And fun fact, tip of your nose, if it is cold, it means you are really engaged in this talk right now. It's also maybe because it's pretty damn cold here, but that's what it is. The difference in the temperature between the tip of your nose and your forehead will give up if you are being mentally challenged with information right now, if you are being engaged, or if you don't care. And of course, the biggest organ of our body, the skin, will give us also the sensing about your cognitive engagement. So that's what I'm doing. I'm studying different cognitive states, different mental states, different affective states of the user. I specifically focus, as I already mentioned, on brain activity, but it's not exclusive. We're going to touch upon why it's not exclusive. But there are other modalities you might have heard about. EDA, skin conductivity, heart rate variability, temperature, the ones that I just mentioned. So today, to be very honest, most of XR and brain sensing actually looks like this. So you have some type of a device, then you have sensors around your head, and it's not really very, very sophisticated, to be super honest. Of course, we are all aiming for much more invisible, seamless interfaces, where you can maybe change from one virtual environment to another, from digital to real life, and you would not even notice, or anyone else would not notice. However, to be honest, just before we're doing that, there are quite a few challenges we still need to solve. So first of all, well, you can see these are some of iterations of the systems I have been working on and using over the past 10, 14-ish years. And, well, on one of the photos, I look like an octopus. On another, well, it's really wired systems. They're pretty expensive. They take quite a few minutes, if not half an hour, to set up. They're usually actually gel-based, so you would have additional shampooing for free for your user. And of course, it's not super comfy. Even if you come to the fancy lab like MIT, within 1 hour you will hate me, and whatever I'm gonna pay you as a thank you, not gonna change your opinion. You're not gonna want to come back. But current XR does, the state of the art does move forward. It's not staying in its place, definitely. Quite a few papers we covered in our review, so you can check those out if you're interested. Fun fact about everything that you see on this screen is that they only make use of 1 to 5 sensors, electrodes most. So 1 to 5. So why would you wear this whole cap or headset, gel-based? Why do that? So the idea is, what if we can try to integrate the sensing? If it's just a couple sensors, let's try to integrate it within the existing XR headsets. Specifically, for this project, we work with HoloLens 2 team. And what we have done here, we have investigated different types of attention that we can pick up while you are wearing a HoloLens 2. So one of the examples is called internal attention. Examples of internal attention would be me asking you, what have you been wearing 2 days ago, or even yesterday? Do some mental calculus, mental math in your head. Tell me the names of birds or animals starting or ending with the letter B. This will be internal attention. So you are internally processing something without actually paying real attention to what's happening outside, in the real world. External attention, on the other side, would be me asking you to look at this little cute puppy, to count how many letters B you see on this slide. So this will be external attention. So this is when you're externally, truly engaged with a task. Another example, it's called covert visuospatial attention. And this is the ultimate type of attention, because this one can be only picked up using your brain activity. Not a single other modality cannot give you this type of information. How it works is very simple. Try to look right now in the middle of the screen, wherever you want, and then try to pay attention to the left side of the slide, lower corner, where there is a little logo of Attentive You, without moving your eyes. I'm pretty sure most of you will be able to do this task. And this is covert visuospatial attention. You don't need to move your eyes to know what's happening around you. So that's an example of this attention. And ultimately, what if we can imagine some items and they will just appear on the screen in front of you? You think about a soccer ball, and it will appear on the screen of your HoloLens. You think about a cube, it will appear in your Photoshop, which you're trying to paint or add some items. So that's what we have done. So we have had our HoloLens 2, and we have just designed a little 3D holder to hold all of the electronics. So it looked like that. You can see on the right image a thicker printed version in blue, so you can actually see how it fits. And you can see that we are actually covering the visual cortex. But on the left, you can see when it's printed in black, you can barely see it. And here are a bit of the close-ups. Just took like 1 hour on a basic Formlabs printer to print that one out. And the, again, thicker version, so you can actually see how it fits. And it's wireless, and it holds all the electronics. And here are some of the examples. So these are not your fancy videos you have seen throughout the conference, but this is all generated based on your brain activity only. So when a user just thinks about a ball, imagines it in their head, it appears on the screen in front of them. There's no visual stimulation. There's no ball before or after or during. No, there's empty screen. They just think about it, and it appears in front of them. Same on the other screen. We ask a user to play a little game against Cortana, and you just need to be externally engaged in the task. So being externally aware of your surroundings, and you will have a little ball, little soccer ball. If you are internally engaged, you will get a cube. And if within 5 minutes of the game, when the game ends, you have more cubes than balls, well, you lost. So that's just a question. Just be in the task, and that's it. And the example of covert visuospatial attention is the simplest. We just ask you to look at the screen, and we will highlight where you're looking at. Again, you don't move your eyes. You don't do anything. For these 5-second iterations, you don't even blink. You just look straight, and that's it. The idea here is that beyond these little games, and by the way, it's all published, we shared all of the files, so you can actually get this, build it at home if you want to. The idea is that if you're actually being externally or internally engaged within your real life task, we will not interrupt you because we will know that you are being externally or internally engaged. And we will know if you're supposed to be internally or externally engaged in the task. We're not going to break your flow ever because we know exactly what the flow is. But a lot of you, especially if you do actually read some of those papers, would be like, oh, but attention, oh my God, I hear this word all the time. What does this even mean? Attention, so complicated. I'm like trying to process what you're telling me. I'm mind wandering, so am I externally attentive, internally, oh my God. Well, interesting thing is there is a lot of definitions. So you always need to understand what is actually being attentive ultimately means. It's not just a word. In this specific neuroscientific context, that's a lot of different definitions. It could be cocktail party problem or conference problem where you are trying to listen to me, but your neighbor on your right really tries to convince you to go and grab that coffee. It could be visual attention. You're looking at 2 pieces of art, and you're looking at both of them very carefully, the Bastia and the Mona Lisa, but you're being attentive towards one of them more than another. Or you're trying to pick up your coffee, and you see several brands of coffee, but you will be paying attention to one of the brands more to another. And spoiler alert, can anyone tell me actually to which one you would pay more attention here? To Starbucks or to Blue Bottle? Does anyone? Starbucks. You were right, actually. It was Starbucks. You know why? Not even because it has the eyes, but eyes is a good answer. And that's why everything here you actually are is about eyes. It's because it has face. We are such social creatures. We have a whole part in our brain that corresponds to processing of faces. If that little teeny tiny part of our brain is damaged, you will just not, you will function perfect, fine. You're just not going to be able to process faces. So for us, Starbucks, hopefully don't record me now, Starbucks or Blue Bottle, don't put this as a promotion. But yes, Starbucks does work better from branding. Same with the Mona Lisa. It will work better unless I will put another face over there instead of the Bastia's image. But how do we measure attention? Okay, I gave you an example about the XR, but great. Yeah, there's a screen, something appears on the screen, etc. But what about other ways of measuring it? Well, first of all, we did publish quite a big review of what you can do and what types of sensing techniques you can use. As I mentioned, it doesn't need to be really around your eyes. It can be on top of your head, around your ears. It can be while you're sleeping, by the way. You know that during some of types of the sleep you're experiencing, you actually can be primed to pay attention to something. I'm going to talk about this in a minute, but again, over the past 10, 15 years, you might, if you have followed this evolution of the sense, and you might have seen there's a huge push towards wearable, cheap, low-cost, usually it's headband and other form factors. Yes, however, let's be super honest. We are here at XR conference and not even wearing headsets unless we're in the playground over there. Why and who would tell you that you would wear a headband? Even if I pay you a lot of money, like, why would you do that? Well, you would not. But to actually measure attention, you need to wear the system over minutes, hours, days, months, in any environment. Because I want to know if you're really listening to me. I want to know if you actually paid attention to what I was saying. And I don't want to use cameras for that. I do not need to use cameras for that. It can be done much more elegantly. But for this, you just need to wear a device. And it needs to be truly wearable. So we went through quite a few different off-the-market, off-the-shelf, readily available glasses. You can see quite a few of them over there. And the challenge with them is that, as I mentioned, they do break your flow, a lot of them. Most of them do have screens, but you then stop really paying attention to the environment around you. And there is very few devices that have actual closed-loop, real-time feedback, where you actually will know what's happening around you in your surroundings, and the device can inform you without the use of a lens or visual. 97% of information we consume using our visual modality. But what about the other 3? It is as powerful as those 97. More importantly, a lot of people don't have access to the visual modality, either because they are born without it, because it got damaged, or they just cannot use it while they're being in the task, in that specific flow. So what we have designed our own pair of glasses. And fun fact, these glasses, unlike everything else you will see here, they don't have any lenses. Just like that. No lens needed at all. And these glasses, which we call attentive view, have brain sensing modality, have EOG modality, which is tracking of your eye movements without use of any single camera or microphone. Yeah, because the fact that you are moving your eye and your muscle is moving is more than enough to have 100% accuracy to know if you looked left, if you looked right, if you looked up, if you looked down. And amazingly, even if your eyes are fully closed, like in different ICUs, your eyes are closed. Your computer vision there will not work if your eyes are closed. But awfully enough, you can have a stroke, and this is having a very specific signal. Your eyes would be having something which is called vertical palsy, which will be more, you're gonna stuck with your gaze on the left, on the right. This will happen when your eyes are closed. We can pick this one up. Not a single camera can, because that's your physiology. And even more interestingly, we do have modalities embedded in the device, like auditory modality, haptic modality, which will inform you about your stress level, cognitive load, attention, and you don't need to use any lenses. So these are how some of the iterations look like, and we have done a lot of research. We have over 300 users. We have over 200,000 hours recorded. Obviously, we publish a lot of papers, but what is more importantly, we do multiple use cases. We do driving, lectures, safety, LS patients, dementia patients, extreme environments, and all of this out of the lab for the past 2 years. Example of the workplace. You will wear the system, you will do different tasks, and we will be able to actually support you when you need a real break. Not going on your social media break, but like real break. Or driving simulators, this was actually recorded in the lab, it's pretty dark, and this would be actually giving you a wake-up buzz if you are falling asleep while you're driving. And another example, measuring and optimizing performance in extreme environments, where by definition, this is a project which we have with NASA, the requirement is that it is on body, but off screen. That was their two requirements. We need something on body that can tell us about the performance of our astronauts, and it needs to be no screens. That's it, like two requirements. So here, for example, you can see one of our zero-G experiments where users are wearing our glasses. One of the users is actually a person who is blind, and they can continue doing their tasks in this very specific environment. And they are absolutely not obtrusive for their others and also for themselves. And I want to finish this talk with two messages. If something that you need to take away with you, this will be this 2-page reference from Nature. It's open access, because definitely there is a lot of neurohype, but there's also a lot of neuroethics, and we do need to talk about that. So take this reference, 2-page read, open access, excellent paper. And also, I want to encourage you, though we are at XR, to look beyond the eyes. I just touched upon the brain, but there is so much more. Ear, different hearables. Auditory modality is as powerful as anything else. Nose, smelling the smell of coffee to wake you up, lavender to calm you down. Taste interfaces, tasting that food that you don't have access to. Sleep, 1/3 of our lives we are sleeping, we are spending in bed. And of course, eyes. I mentioned EOG as one of the modalities. Cameras are not the answer. They were never the answer. You can have all of that information without the use of cameras. Of course, thank you to the team, and thank you for your attention.